Okay, good morning everyone. So, hope you're having a good day. My name is Piekarski, and I'm a developer advocate at Google. And so my job is to go out and talk about Android Wear. So you may have seen these new wearable devices floating around. So I'm the developer advocate at Google for wearables, and I also work on Glass and Android and other things like that as well. So my job is to sort of go out and talk to people about how to program for these devices, how to use them, how to build user interfaces for them, and things like that. So today we're going to give a bit of an introduction to how Android Wear works. You may have seen it recently. It launched at Google I/O, so we announced the 2 square watches, and then we released some round ones, and there's more watches coming. So there's a whole bunch of really exciting new developments in the field of wearables right now. So I'm going to go through a bit of that today. So we're going to talk about wearables, but I'm going to do some technical coverage of the APIs, but I'm not going to really focus too much on the coding side of things, because there's actually a lot more to the user interfaces on these things. These are very standard Android devices that can do pretty much anything that a phone can do, but the difference is in the user interface for it. So we're going to spend a lot of time talking about that and what it means for the user to be able to use a wearable computer. So before we get started, doing a dive in on this stuff, let's sort of take a step back and think about how people go about using a computer. So what's wrong with this picture here? So you've got a bunch of people, they're sitting around, they're all staring at their phones, and they're disengaged from their friends, they're not really participating in the conversation. And so, this is kind of typical when you go out to a restaurant or wherever. You see a lot of people zoned out, buried in their devices. But they're trying to stay connected with the world, but they're disengaged from their friends around them. So we've been spending a lot of time sort of looking at this and thinking about it and so forth, and sort of trying to understand more about how people go about using their technology, how they go about staying connected with things, and what we can do to try to improve that. So we all know how useful phones and tablets are to our day-to-day lives. I mean, everyone's got one, everyone's using them all the time. But what can we do to improve that, and what are some ways of doing that? So if we look at this picture here, you can see someone's using an Android Wear device. So the really neat part about Android Wear is that it allows you to stay in the moment when it's appropriate, but also get the information that you need at the right time in just a glance, just by looking at your watch. And so let's try to understand that by looking at it in a slightly more detailed way. So if you look at your typical day-to-day life when you're using a phone, you are walking around doing your thing, and then a message comes in. And so you get your phone out, you unlock it, you pull the app up, you look at it, then you go, oh, look, I've got some emails. So you read them too, then you browse the web, and the next thing you know, 30 minutes has expired, and you're like, what happened to my day? So this is pretty typical. A lot of people have trouble context switching, and the phone kind of sucks in your time. So there's a lot of time involved in all these different steps every time you want to check on a notification or something. So it has a very hefty time and attention cost that affects your day, helps you become distracted more, and things like that. And so this isn't really ideal when you're hanging out with people or in a meeting or whatever. You really want to try to be as engaged as possible. So this is a sample of what your day could look like using a wearable device. And so there's the same kind of interactions involved in that you're checking notifications and so forth, but you'll notice that there's a much reduced overhead of the interactions themselves. Every time a notification comes in, you just look at your watch, you see the notification, and you can either ignore it or you can dismiss it, or do something really quick. And that's the whole point of this, is we're trying to reduce the amount of time you spend disengaging from the real world that you're in. And so this is the way we word this, is we say that you're more present in the real world, but you're also more connected with the virtual world that you're in as well. And so you kind of have a win-win situation for both of those things. So what does this mean when you're a developer trying to write apps for a wearable, and how do we go about designing good user interfaces for it? And so the most important thing here is that, to start with, and this is very important, it's a fundamentally different user interaction model. This is not a phone anymore. This is a wearable device, and we need to think of it very differently. So this here, these are 2 screenshots of Android Wear devices. So there's the LG square one on the left and the Samsung square one on the right. This is the Moto 360 on my hand here. And so these are the 3 commercially available watches right now, and there are others launching very soon. So as you can tell by looking at this device, it's very different than a traditional cell phone that most people are typically used to dealing with. And so to really nail the user experience on this thing, you have to rethink everything. So when you're considering what you want to do with the watch, a lot of people are like, oh, I'll just take my phone app and I'll just shoehorn it into a watch and that'll be perfect. It'll have a little tiny buttons on it and we can type text messages and things like that. That's not the solution to what you're trying to do here. So you've got to step back from this for a second. And a good sort of guideline to think of is say, what things couldn't exist before can now exist because we have these wearable devices. And then you should build that. That's sort of a good guideline of, I wanted to build an app that would do something particular and it would be very immersive and interactive on a wristwatch, but I couldn't build this before. It just didn't work on the phone for some reason. That's a good guideline of something that you should probably build on a wearable. Not everything should be on a wearable. So think of those kind of interactions and then focus on that. And the next thing is you have to actually try it. So a lot of people write their apps on desktop machines and they use an emulator to test it out, but that doesn't test out the user interactions. You have to go and try it out for yourself outside while you're running or doing whatever it is you're supposed to do. So it might sound silly, but if you're building a running app that's designed for people to track their run or whatever, it doesn't make sense to test it on a desktop because it might be that while you're running, you can't push the tiny little buttons you've made on the screen. And that's when you discover that certain things work and certain things don't. If you're trying to make an app that you talk to, if you're going to be using it on a noisy train all the time, that might not work either. So you've got to think about what is the use case for my app? Where is it going to be used? Who are my customers? Do they have tiny hands or big hands, or do they run a lot? You've got to take these things into consideration. And if you're doing user studies, make sure you try a bunch of different people because everyone has different needs, and make sure you make the fonts big enough. There's all these different issues that you've got to take into consideration. And so there's a lot of really cool opportunities in this space now because these devices are out. They're low cost, they're easy to integrate into Android, but you've got to get the experience right, otherwise people won't find your app exciting and interesting to use. So, as I said before, you've got to try it, very important, and so definitely a good idea. So, now let's talk about what it means to try to write an app for one of these wearables. So this here is your current app experience on your phone. So we've trained users over time to collect lots of these little shiny icons on their phone screen, which they go, I want to send an email. I'll click on the Gmail app. They then load that up. They then send their message and so forth. So this works great on a phone because the phone has a relatively large screen and a lot of real estate to put icons and swipe gestures and things like that. But if we just go and put these shiny objects onto a watch, all of a sudden now, look, you've only got 4 icons on a tiny little watch screen there. So you're going to swipe through 1,000 apps on your screen to try to find the one you want. That obviously doesn't work either. So it doesn't really make sense to use the same paradigm on a watch compared to a phone. And so we really need to try to get away from this. And so how do we get past this whole grid of icons and move on to something else that's different and has like a revolutionary user interface design that's really perfect for wearables? So this is the Android Wear interface. So I'm going to go through it in detail now to explain what the different parts of it do, what the user sees on the screen, and so forth. So in this interface, we have 3 key concepts here. It's simple, it's glanceable, and it's built around micro interactions. And so the interface is divided into 2 primary behaviors, which we'll go through now. The first one is that the user talks to the wearable. So when you want to do something, you bring your watch up and you say, "Okay, Google, how tall is Abraham Lincoln?" And it transcribes it on the screen. Hopefully my phone's working down here. Oh, there we go. How tall is Abraham Lincoln? 6'4". So you can ask questions and it'll give you the answer, puts it on the screen of the device. So a lot of the interaction with the watch is done via speech interactions. You ask it questions. And you can think of these as what we call actions. So the user can say, "Okay, Google," and it brings up a list of all the different things that are possible. You can just speak them. You can also select them with your finger as well. But there's a variety of different actions that you can launch here that are shown in the animation there. And there's a whole bunch of things like, take a note, send a message, set an alarm for me, book me a ride, things like that. So it's a pretty powerful way of interacting with the device. The wearable also has the ability to communicate information back to you. So we have these notification cards that pop up, and we call these the context stream. So there's a whole bunch of events and interesting things in your life right now going on. They show up in the context stream, and you can swipe through the cards and find out things like what the weather is right now. And this animation here will show some more examples. So there's a hotel reservation and a flight coming up for you. And the goal here is we want to show things for you that are at the right place at the right time for you. There's no point showing you, hey, go to the grocery store tomorrow to buy all this stuff, because it's not tomorrow yet. You want to focus on things that are relevant to you right now that are important. You don't want to pester the user when they're not interested in what your app might be saying. So this framework here of speaking to the wearable and getting feedback via the context cards, this is the interface for Android Wear, and this is what sets you up for success when you're designing your wearable app. So to make your app successful when it integrates into Android Wear, it's important that you carry this philosophy in your application as well. So if your app does something really different or really weird compared to what people are expecting, they're obviously going to have a hard time using your application. So you want to make sure that your app follows the design guidelines of how to write a good app. So later on, I'll show some links to documentation that shows you the design guidelines for Android Wear and the best ways of building user interfaces. But we'll go through some more examples. So these are some cards here of different parts of Android Wear. So you've got the Google Now card that shows you how far your destination is to get home. Driving directions show up from Google Maps as you're driving around. You can send text messages, and you have the music controls for when you want to control the music that's playing on your phone right now. So the whole point of Android Wear is that we're sort of building this kind of a personal assistant that integrates in with your life. And so it feels personal and global, it feels simple and smart, and it's unobtrusive and ever ready to deal with the questions that you have and to do what you want to do. And so definitely want to be doing these kind of experiences when you're building an app for Android Wear. So as I said before, it's very important that your app doesn't pester the user when they don't want to be annoyed. So this card here is relevant because it's like, hey, you're about to leave to go home right now. Here's some information about your drive home. So it's important that your app is aware of the user's context. So think time, location, and physical activity. If a person's sleeping, there's no point bugging them, but if they're running, maybe some running advice would be helpful, things like that. And so when something becomes appropriate for the time right now, your app can generate a notification card into this stream here, and it will then be displayed to the user. So these notifications make Android Wear timely, relevant, and very specific to what the person's doing right now. The next concept is glanceability. So people have been wearing watches for hundreds of years, and they're very used to just pulling their watch out, oh, it's 11:53, put it down again. They don't want to spend a lot of time immersing themselves into it. They want to get what they want and then put it back again. This is what we mean by glanceability. It's this ability to see something in a split of a second and then get back to what you're doing. And so it's interesting because on a phone, you want to try to get the user to engage as much as possible. On a wearable, you want the user to get in and out as quickly as possible. You don't want to hold too much of their attention because they've got better things to do. We're trying to make computing sort of disappear from their lives, not saturate them with having to spend too much time with it. So Android Wear is all about being fast, sharp, and immediate. So when we looked at the examples earlier, we talked about how the user has the ability to ask questions and the wearable can give information back. And so we mentioned before that it's kind of like having a personal assistant. And so think of it as being, you've got this little assistant sitting on your shoulder and you're like, hey, I need a ride, get me out of here. And the personal assistant takes care of it for you. So the Android Wear device should always be on hand and ready to answer your question. It doesn't make sense if the user's like, hey, book me a ride, and then you've got to click through 40 million dialog boxes to answer a bunch of questions. Just do it. We'll deal with that later. So you really just need to give the user back their information, what they want as quickly as possible. And so some keywords here is that Android Wear is helpful, respectful, and responsive. Don't bug the user when they're in a meeting. Don't bug them with dialog boxes that are things that are not important right now, things like that. We also talked about the fact that you're going to be running this, you're going to be running outside or walking or doing things like that. So it's very important that we use very simple interactions. Don't build super complex user interfaces with tiny buttons. Try to use large touch and swipe gestures. You can use hand presses, you can use taps, things like that. Use gestures that are easy to do for when someone might not be looking at the display or when someone might be moving quickly or running or whatever. So try to keep things gestural, simple, and fast for the user as well. So you don't want to have to do too much fine-grained finger motion while they're using the device. So those are some little guidelines about things you should keep in mind while you're dreaming up your Android Wear interface for your users to use for your app. So now, I'll mention later on, I'll show some links to some documentation, so definitely read through that. So just because you're an Android expert doesn't mean that you're an expert at designing for Wear. So you're an expert in that you know the APIs and the tools and everything like that, but you really do need to rethink the user interface. I mean, if I showed you these cards here, it doesn't look like Android. It looks like something completely different. So the people at Google who designed this have rethought the user interface for a wearable completely to be what the user needs to see. Now, underneath it, it happens to be that the APIs are very similar, but it's very important that you keep the user interface in mind. So now that we've talked about the user interface for this, now we can start going through a bit of a discussion as to how to go about building apps for these devices. So there are two ways to build an app for an Android Wear device. The first is through notifications, and the second is via building a custom dedicated app that runs on the wearable itself. These are actually full-blown Android devices that are very powerful. They have OpenGL support. They have, they can do everything that a standard phone can do. So they're very powerful, but with great power comes great responsibility. And so we'll talk a bit more about how to go about building nice apps for these devices. So the first thing is via notifications. So on Android devices, so this is a Nexus 5 here, but when a message comes in, you will get a notification at the top that says, Hoi Lam has sent me a message that says hi. So it shows up on your phone. Now, on a wearable, you get a pop-up card in your notification stream that looks like this. So you get the person's face in the background, you get a notification that says hi, and then you have the ability to reply to it and do a few things like that. So how do we go about getting these notifications onto the wearable from the phone? So in order to get this done, you do nothing. So the cool thing is that this already works out of the box. So when we launched these watches at Google I/O, every app on Android that supported notifications worked already. We have a companion app that runs on the phone, and the companion app synchronizes all of your notifications from the phone to the wearable. So every app that does notifications just works out of the box. So this makes it very easy, and so every app that does notifications just kind of works, and that's great. The next thing is that if you have enhanced notifications, like when you're playing music, so if you've implemented the remote control client API on Android, that's the API that when you're on the lock screen of your phone, it shows you the play, pause, start controls for most music apps. If you've implemented those controls, they can also be shown on the wearable as well. And if you've implemented the remote control client API, there's no work required there either. So once again, the companion app magically synchronizes all of the remote control client interfaces, notifications, everything, so that it's all available on the wearable. So you're already off to a good start if you've got an Android app with notifications, because you don't have to do too much to get started. Now, the nice thing is that you can actually add extensions to further support the wearable in a more powerful way. And this is where, with a little bit of extra work, you can get a huge benefit for your app. So the first thing we have are extensions for wearables, and the first one is called Stacks. So what Stacks does is when on your phone, when you get a notification, it says you have 6 emails. Now, it'll show up on your watch normally as you have 6 emails. But with Stacks, you can actually click on that notification and expand those emails out to see individual messages. And then you can reply to each one or do whatever you want to do. So the nice thing is that on the phone, it looks exactly the same. But on the wearable, you get extra information that's suitable for your wearable. Pages is the ability to add extra cards to the right with extra information. So you can see here we've got 10 minutes picnic with Rachel, and then if you swipe the card, you get to see more information like please bring some French bread, good cheese, da-da-da. So that wouldn't show up on the phone because that's just a regular notification card. But if your app knows about wearables, you can actually add this extra page extension very easily. It's a couple extra lines of code, you slap in some extra text, and the API takes care of it for you. And finally, we have replies. Now, this is where I think the real big win is. So if you get a notification that says, hey, you received a message that says hi, or where are you? Now, if you hit the reply button normally, it'll bring it up on your app with the reply feature, and you can then write a reply. But if you add the reply wearable extension, it actually brings up a dialog box on the wearable that allows you to speak into it. And you can say, I'm running 5 minutes late. It will then transcribe that text message, send it back to your app as a string, and now you have speech recognition support from a wearable built into your app, and it's literally a couple extra lines of code to add this support. And the nice thing is that when you add this code to your existing application, it does not break compatibility with any devices. So if your app runs on anything that's Gingerbread or later, you can add these extensions and it won't break anything if the user doesn't have a wearable. If they don't have a wearable or they're running on Gingerbread or later, it just works with that problem. Yeah.
You know, a couple slides ago, you said that it's not a good idea to, sit here and be scrolling through as you're looking through your apps or whatever.
Mm-hmm.
So why would you incorporate something like this with it being the same type of user interaction?
Yeah, this is meant for limited amounts of info. So if you have like this one here, like a standard notification is an appointment is coming up, but you want to know the address for it. Now, the alternative would be to pull your phone out, get the address of something else, but you can have extra cards that are optional. You don't have to look at them. So the thing with the launcher icon analogy was that if you want an app that starts with Z for Zookeeper or whatever, you have to swipe through 1,000 apps to get to the Z app. In this case here, the most important piece of the notification is the picnic, which is in 10 minutes. The address is here, or the extra details are there if you want it, but you can actually just get rid of the card if you don't want it. So the information is there if the user wants more information, but it's also they don't have to look at it if they don't want to. So that's kind of the nice thing, is it allows them to get more information if necessary, but not required. But yeah, so the cool thing about this stuff is it's backwards compatible. So you don't break your old app. So if your app runs on Gingerbread devices, you're not going to be forcing your users to upgrade to Gingerbread, or to Ice Cream Sandwich or Kit Kat or any other release. So that's kind of the big win here, is that you can very easily add these extensions to your existing app on the Play Store, and it just kind of works without breaking anything for anyone. So that's one of the cool things about notifications. So that's a quick discussion of notifications, which is a very simple way of getting started with making Wear apps. And it's something that you can go and do very easily. But now we're going to talk about making full-blown apps. So these are for experiences that are just where you want to do something that the notification system doesn't support. And so we're going to go through how to go about building those now. So when you're building full-blown apps on a wearable device, there are sort of three things that are important that you need to know. The first one is you need to know how to send data between the wearable and the phone. The phone is sitting in your pocket or something else like that, but they need to communicate, because the watch takes, calendar information, it takes notifications from your watch. It needs to be able to sync these back and forth. And the notifications are actually synchronized using the same API that I'm going to show you here. We're going to talk about how to build custom user interfaces as well. So while the notification cards work for certain things, there are some applications that need to run full screen. You might be making a mapping app or something like that, and you really need a full screen experience on the wearable. And then finally, we're going to talk about how to hook into the voice actions, because Android Wear devices have a very powerful speech recognizer and text transcription service in there, and so you'd want to be able to leverage that for your application as well. So while your device is running, you've got your phone, your watch, and they communicate with each other via Google Play Services, which is a library that Google puts out, which has different functionality for doing like mapping and playing games and things like that. Well, the wearable support is also embedded into Play Services as well. And so Play Services takes care of sending messages back and forth between the wearable and the phone. So there are three kinds of data exchange that you can do here. The first one is called the Node API, which helps you to know when devices are connected to each other. So if the wearable and the phone disconnect from each other because they're too far away, you'll get a message via the Node API telling you this. You could use it to build like a Find My Phone app. So if the phone goes for a walk or your watch goes for a walk, you'll get a notification on both of them that says, hey, have you left one of your devices behind? You'll be like, oh, I left my phone on the seat, or I left my watch somewhere. So you can use it for something like that. We have the Message API, which is used for sending fast, low latency messages from phone to wearable. And the important thing with these messages is that they're unreliable in the same way that UDP packets are unreliable. If you send one, it may be lost if the device disconnects all of a sudden during the transmission of the message. But it's a low latency way of sending messages, so it's more for high performance things where you want to send lots of updates. We then have the data synchronization API, which is useful for synchronizing lots of data between a wearable and a phone. So for example, if your watch stores a bunch of sensor data, you would save it to the data API, and then later on when you bring the watch and phone together, it'll make a copy onto the phone as well. So they don't need to be connected at the time, but the synchronization layer guarantees that eventually when the devices are brought together, that the data will exist on both of them. And you can use this for the communication between your phone and the wearable. So this one, because it's reliable, there's a bit of more overhead, so you need to choose between the message or the data API depending on which one is the most suitable for your application. So let's quickly go through the code snippets for how to do this. So in the Node API, there is a function you can call getConnectedNodes, which returns a list of nodes. And so this would be a list which would contain your wearable and your phone. And because it returns an array, the API is designed in a way that potentially in the future it could support many devices. So when you are sending messages, you should write a for loop that goes over this list here to make sure that you send it to every device that's connected to it. So just recently, they announced that Glass supports notifications on Wear. So Google's putting a lot of effort and resources into using this data API for talking to wearables and more than one maybe. So keep that in mind. The next thing here is that if you want to receive the connect and disconnect messages, you implement this Node listener interface, and it'll call your methods there. Now with the Android Wear, when you download the SDK for it with Android Studio, there's actually a sample in there called Find My Phone, which implements this interface here, and it shows you how to go about listening to those messages. So that's kind of a interesting little tidbit there. If you want to send a message, the API is very simple here. Send message, you pass in the node ID, and then the data you want to send. And once again, make sure that you do a for loop over all the node IDs so that you don't accidentally only send it to the first one, because there might be more than one device. And the API, if you want to receive messages, is you implement this message listener. It simply just gives you the message when one arrives. So it's a very easy way of sending messages back and forth. We don't want programmers to have to worry about dealing with all the intricacies of Bluetooth and maintaining connections and synchronizing data. We want to take care of all that for you. And then finally, we have the data synchronization API, which is where you create these things called data items, which are represented by a put data request. And you can stuff in there bundles that contain a key value store of strings and values, strings, integers, floats, byte arrays, things like that. And then you can be notified when those values change as well via the data listener. So these are pretty easy ways of doing synchronization, and synchronization is actually a very hard thing to do by yourself. So you definitely don't want to be making your own synchronization system. And I've actually had a few people ask me, is it possible to do my own MySQL database on the watch and store information? You can do that, but you probably should be using the data synchronization API to store your data. It does a lot of the same things for you, and the data is synced magically to your phone as well. So if you did your own database on the watch, you would then have to use the same API to sync the database over to the phone anyway. So why not just cut out the middleman and use it anyway? So in general, this is a good API to be using for doing things like that. So finally, to bring this all together, you declare a service on your wearable, and you add it to the Android manifest XML file. And what happens is that when a message is sent from the phone, the Google Play Services API looks at it, works out where it has to go. It then sends it to the appropriate application running on the wearable. And it knows that this service is the one that's registered for it, so then it delivers the messages to you. So the Google Play Services starts up your service automatically. You don't have to worry about this stuff. And it takes care of the security as well. So the way it works is that it only will send a message from your phone app to an app running on the watch that has the same package name and same version ID. You're not allowed to vary them. So it's critical, actually, to get this right. Version ID and package names have to be identical. If you get that wrong, it won't work. So now that we've talked about how to send data, now let's talk about how to build custom UIs that run on these wearables. So we talked before about notifications. So the notifications have those little white cards that pop up in your stream, but it's also possible to make custom notifications as well as full screen apps on the right here. So let's talk about custom notifications first. So in general, use the notification synchronization API if it's suitable for what you're trying to do. If it does the job, just use that. It'll make your life easier. We take care of the coding for you. But if you want to do more than that, you can actually make your own custom cards that have little graphics and things like that inside the card itself. Notifications don't normally allow you to control what appears on the card. So if the existing styles don't work, you can create the different layouts here, and you can actually create the notification on the watch. It'll pop up a card on the watch, and you can interact with it just like a regular card, except it just gives you more flexibility. So to do that, you need a custom app running on the wearable. So we're done talking about notifications, but now let's talk about custom UIs. So this is the first time actually we've had to deal with round devices. So this Moto 360 device here has a round screen on it. Now internally it's represented as a square frame buffer because that just makes sense for software purposes, but the screen is round. You can't just put a big blob of text on the screen because it'll be chopped off by the round corners of the edges of the screen here. So you need to take round into consideration. And it's not good enough just to design your app for square and go, oh, it'll just work for the round people. It won't, because things will be chopped off. And there's a lot of round devices now. So the cool thing about the launch of the Moto 360 is we've brought round in. Watches have been round since the dawn of time, basically. So there's going to be a lot of round stuff going on. So it's very important that we understand how to deal with it. So if you look at an app that wants to display some text and some pictures, for example, on a square watch, you would have some small borders around the edges where you wouldn't want to draw anything. And then you put your text on, and you can see here that that's the square region that we can draw a blob of text in or something like that. Now in the case of the round watch, you can see here that we've made this pink square fit within the confines of the roundness of the display. But we have much wider margins around the edges that we can't use for things because it'll get cropped off by the screen. So just, you got to take that into consideration. And we have a custom UI library that we've provided which helps you to get these layouts right to make them easier for you. So you don't need to worry about fitting everything against the round edges. We've got some support for things like this to make it easier for you. The neat thing is the pictures in the background, actually, you don't need to do anything with them, because generally pictures of people's faces and things like that, if you crop the edges of a person's face, the person's face still fits in the screen. So you'll notice a lot of Android Wear apps, when a text message comes in, they'll put your image in the background and then put text over the top of it. So that's a common user interface that's used by these apps. So let's now talk about this wearable support library, which helps you to build these kind of things, and then we'll talk about some of the features that it offers. So the first thing you do is in Android Studio, you add this one extra line of code to your build.gradle, which includes the wearable support library. And Android Studio makes these things a lot easier. If you're using Eclipse, if you're a new user who doesn't really know Android that well, I would definitely recommend using Android Studio to create your apps. It's a lot of wearable support. It deals with these library dependencies out of the box very easily, whereas in Eclipse, it's a little bit harder. If you're a veteran Eclipse user and your app is built around Eclipse, you can do it. And if you've been using Eclipse for a long time, you'll know how to do it. But definitely, new users should use Android Studio. So what things are provided in the support library? So some of the sort of important ones I think are interesting. First one is dismiss overlay view. So when you're running a wearable app, there are some apps that want to take over the whole screen. Now, traditionally on Android Wear, use a swipe to the right gesture to get rid of a notification. But some apps, you might want to be making a scrolling map or whatever. The swipe to the right, you want to actually slide the map to the right. If that's happening, you have no way of quitting the application. Dismiss overlay view is a detector that basically you press and hold on the screen for 2 seconds, it brings a red X up, and you can click that to close the app. So it's kind of like a press to exit functionality. We have watch view stub. On Android, we have a layout system where you specify the layouts of your applications using XML files. Watch view stub allows you to provide a round XML and a square XML, and it will inflate the appropriate one depending on if you're running on a round or a square watch. So that's definitely very useful if you're trying to deal with that previous scenario where you want to lay things out differently depending on which kind of watch it is. And so if you've developed Android apps before, Android Studio has this drag and drop editor where you can create layouts. You create 2 of them, one for round, one for square, and then you put your app out. So one little gotcha that I've seen people get wrong here is that they write the square XML file and they forget to do the round one. They push it on the Play Store and then it blows up when someone with a 360 downloads their app. So make sure you test on both round and square. That's very important. And then box inset layout. This one's quite interesting because what it does is it says, hey, if it's a round screen, I want you to box whatever I draw within a confines of a box that fits on the roundness. So on that previous image I showed with the pink box, it was designed to fit within the roundness. Box inset layout takes care of that for you. And so it allows you to say, look, I don't really want to deal with any layouts here. I want to have one layout for all apps, make it fit within a square that fits on the round. And you'll never have anything leaking out or touching the edges then. So that's a good thing to look at. And there's a whole bunch of other things in here as well. A grid view pager allows you to build swipeable apps that swipe between different cards. A whole bunch of interesting things here. So finally, voice actions. So as we said before, Android Wear is built around a lot of concepts to do with speaking actions into your wearable. And so we want to provide the same functionality to our developers so that they can take advantage of that themselves. So with Android Wear, the first thing we have are system-provided notifications. And so these are task-based, and they're built into the wearable platform. Things like take a note, for example. And so they're specified with intent filters, which we'll talk about in a sec. The next thing we have is application-provided actions, which is where you say, OK, Google, start my app name. And then we have free-form speech, which is where your app can pop up a box and you can speak whatever you want into it, and you'll get back a string that contains the information, whatever you asked for. And so you don't have to worry about building the speech recognition part, because we've done that for you. And there's a whole bunch of people at Google whose job is to support the speech recognition. And so that's what these people do. You can focus on making your app. So how do we go about providing a system-provided voice action? So in your Android manifest.xml, you simply say, I want to declare the intent for take a note, for example, and your app will then be delivered those events when they occur. So things like take a note, set an alarm, and so forth. And here is a list of all of the ones that are supported when I wrote the slides, although we keep adding them, with each new release. But you can do things like asking for a ride, take notes, set alarms, start fitness workouts. There's a lot of fitness stuff because Android Wear is sort of a big thing for, while people are running, they want to do fitness-like activities. So there's a lot of support for those kind of things. So you can register for those intents there, and then you can write apps that support them and deal with them. Now, if your app doesn't fit into any of those categories, you also have the ability just to have someone start your app by name. So if you're an Android programmer, you'll notice that this is the same as the way you declare a launcher icon in an Android manifest already. It's the same thing on a wearable. You can declare a name for your app. And so you can say, OK, Google, start my running app, and it'll start it up. The trick with the naming of your app is to give it a name that's easy to recognize by a speech recognizer. If you have some really weird app name that's not pronounceable, or if your app logo is like a square, and no, it's not going to work. So you need to make sure an app name is pronounceable by a user in a consistent way so that the speech recognizer can capture it. It's actually possible to have multiple app names as well by using a launcher alias. So keep that in mind, but make sure it's pronounceable and easy to say, so that's important. And finally, if you wish to declare your own speech recognizer, a couple lines of code, you just throw it in there, say, hey, recognize some speech, kick off the activity, and then Android will call back to your app. So it will call back to your app with the string that was returned, and then you can do whatever you want with it. So for example, I've seen people making these calculator apps where you type on the screen. It'd be much better if it just popped up a dialog box where you say 4 plus 4, and then it would then give you that string 4 plus 4. Your app could solve the answer and then print it back. So the speech recognizer is a very powerful way of interacting with the user. So a little bit of a note about how these apps are distributed. So wearable apps on the watch are distributed via the phone. So right now on a phone, if you want to distribute an app to an Android device, use the Google Play Store. You upload your app to the Play Store, the user downloads it on their phone, it installs to the phone, and then they can play the game or use your app. With a wearable app, what you do is you build the wearable and the phone components, and you embed the wearable into the phone app. You then put that to the Play Store. Now what happens is that the app lands on the user's phone. It then extracts the wearable app out and installs it onto the wearable, and it takes care of it for you. So the nice thing is that if you add wearable support to your existing application on the Play Store, your users will just get it for free one day. When you upload it, a couple hours later, bang, it'll just be appearing on people's watches, and they can start using it. They don't need to go and download a separate app. And you can charge for it, do whatever you want to do, like the same with your phone app. The same functionality works like that as well. So it's a very nice distribution model because you don't have to worry about dealing with payments and all this kind of stuff. It's just taken care of with the standard Google Play infrastructure. As I said before, it's very important that the package names match between the wearable app and the phone app, as well as the version ID being the same as well. Otherwise, it won't communicate. It's sort of a security feature to make sure that apps only talk to the corresponding app on the other device. So Android Studio includes a whole bunch of samples and so forth about how to go about deploying, making your own Android Wear app. So it's definitely a good idea to try to play with some of those samples first, get a feel for them, play with building them, and understand how they work. And that's a really great way to get started. And Android Studio also has templates that are built in to help you do these things. So definitely check that out. And so that's it for notifications and apps. So sort of to conclude here, there's a few sort of takeaways for you to get started with Android Wear. The first one is on our developerandroid.com/wear site, we have information about the tools you need, Android Studio, the different pieces that you need to go to get started. The second thing we have is design guidelines for Android Wear as well. So we talk about what the designers of Android Wear were thinking and what they envisage for a good wearable app. So it talks in more detail about the concepts that I've talked about today. So how to make apps that are easy to use and touch, and the kinds of graphics that should be used on the screens. They talk a lot about that. The thing with Android Wear, as I said before, is that while it runs Android underneath, the user interface is very different. And so there's a lot of important things to consider there. We have a developers group on G+, so I moderate a forum there called Android Wear Developers, and people post questions, I answer them. I also troll on Stack Overflow as well, looking for answers. So we really want to try to, I work on a team called Scalable Outreach, and my job is to try to reach as many people as possible. Because if you've got a question, there's probably 10,000 other people who have the same question as well. So feel free to post questions on there, and me or one of my colleagues will answer them, because we want to share that information with the public. And then finally, I'm on Google Plus as +Wayne Piekarski. And so I post a lot of hints and little, I spend a lot of time writing apps for Android Wear on the side, so I can learn the kinds of challenges that developers will face. And if I run into something, I'll write a blog post about it or a little article talking about it. So follow that if you want to sort of keep up to date with new things that are happening on Wear or little questions that developers might have. So that's it for today. So thanks very much for coming. And we've got some time for questions, because I think the session finishes at 12:30. So thank you, and I'm happy to take any questions. Yeah.
In the future, do you see Android Wear becoming a Google Play installable launcher?
A Google Play installable launcher. What do you mean by that? Sorry.
So like Google Now Launcher, could there be a Google Wear launcher?
Well, see, the Android Wear devices already do Google Now cards.
Yeah, but yeah, I was just thinking of it. Android Wear as just a launcher. So if someone does create a device that's small enough, like a watch 320 by 320,
yep,
and they want to have full Android on it, but
yep,
they also want to have the ability to do Android Wear.
You can do, I mean, so they are kind of different. So the Wear and the phones are done slightly differently, but you can make custom launchers right now. I've seen them on the Play Store where people have made their own custom icon launchers.
I was just thinking that, I was wondering if Android Wear would eventually become a launcher.
No, it's a separate way of doing things. It's 90-something% Android, but there's a little bit different. They're also, the firmware and stuff is done differently as well. So we push updates out for all the OEMs simultaneously and things like that. So it's done slightly different than phones are. But it is possible to customize a lot to the point where you could make them pretty much similar. So yeah, question? Yeah.
Yeah, what new features will Android L bring us?
Okay, so L had a total sort of rework of the notification system. So notifications on L have the ability to set privacy information. So when notifications show up on an L device, you can control, will the notification show up here with the full text, or is it slightly private where it only shows the app name, or is it a secret mode where it shows nothing? So those kind of notifications in L were changed considerably, and so they sort of, there's a lot of, they'll have an impact on how notifications will show up on the wearable. Otherwise, apart from that, L doesn't have too much impact on these things here. So this device is built around KitKat right now, like internally. And so L is being brought out on phones right now. Doesn't add too much else. So these aren't running L yet. Yeah.
What is the level of security, or not security, but when I send out a notification, I want it to be maybe not on the lock screen, but I want it to be,
on the wearable.
What level would it need to be to show up here but not on the watch?
I haven't played too much with L yet myself, but if the notification shows up on here, then it'll show up on the watch. If you want to make something that never shows up on the phone, but shows up on the watch visibly, you can actually like launch the notification from the watch, and then it will only be visible on here. So there's an SDK sample called synchronized notifications that shows how to do those kind of things. So you can actually do different notifications on phone versus wearable if you wanted to do something like that. So you can vary it. There's another method called set local only, which is where you can make a notification on the phone that never shows up on the wearable. So you do have some control as to what shows up here, what shows up there, and stuff like that.
Is that using just the regular notification system?
Yeah, so the wearable extender has the set local only thing. If you want to do the notification only on the watch, then you have to do it with a separate app. Yeah.
If your watch gets stolen, is there anything that sort of auto-locks it out or something that says, hey, you're not, John
So
Doe?
what happens with the wearables is that we don't synchronize your entire calendar and passwords over to the wearable. The trick is we only synchronize notifications to the wearable, current events like maybe your calendar for the next couple hours, but we don't dump your entire calendar on there. So if someone did get your watch, there was only a limited amount of information they can extract out of it, which is nice because you don't have to unlock your watch every time you do something. And I've also seen with L, they've got the ability to do unlock. Like I think if you bring them together, you can unlock your phone and stuff like that. So there's a few different things you can do like that. But the watches generally do not store too much personal information on them, which is nice because
Yeah, it's no big buzz.
yeah, if you want to have something that's unlocked, then you don't really want to be storing too much on there because that would be a problem. So yeah. Yeah.
Do the API do any additional encryption with what the data is sent?
I'm not sure. I mean, it uses, Bluetooth to communicate back and forth with the devices. So Bluetooth implements encryption. Now, of course, if someone discovers a security flaw in it, that would be a problem, but I imagine they would update it if such a thing happened. But in general, it's encrypted to stop simple eavesdropping. I don't know the details of it, though. Yeah.
Would it be possible at some point in the future for an Android watch to talk to an iOS?
I don't know. I mean, right now, there's a lot of sort of communication that goes back and forth. So you have to take the notifications and sync them over. For doing apps, you need an app that actually runs on the phone to be able to synchronize it all together. So right now, the API only supports Android devices. Yeah.
Is there any future consideration for it not have to sync to a device at all? So you're finding, is there plans in the API that the watch itself could wear it?
Yeah, well, the nice thing about the API, I mean, I don't know what the plans are for this, or I haven't seen any, and I wouldn't be able to tell you if I did know. But the thing about the API is the way it's written is it doesn't have Bluetooth or Wi-Fi written anywhere in it. It's just send a message, receive a message. Where's a list of nodes, get a list of nodes. So from looking at the API, it could be possible to sync to a device not via Bluetooth. Like there's nothing forcing, because right now these things are paired via Bluetooth, but there's nothing in the API that requires it to be Bluetooth. It could be Wi-Fi, it could be Zigbee, it could be something else. I mean, there's a lot of flexibility in how it could be done. So there's nothing stopping it from being that way. So in the future it could change, and the API is written in a way that your app would just continue to work. Any other questions? Yeah.
Are there plans for more biometrics rather than, the biometrics in the Samsung, it's not constant, it's just a on-demand
Yep.
heart rate sensor. Is there plans for biometrics that are continually checking heart rate? Or
Okay, so the question was about biometrics. So each OEM gets the ability to build hardware into their devices. So like the LG Square one doesn't have a heart rate sensor, the Samsung one does, Moto does. Each watch has different levels of hardware functionality and so forth. If the heart rate sensor doesn't do what you want, you can actually, let's say, I know fitness companies who are making their own fitness apps where they might want to provide their own chest strap or something like that. Now what you would do is the chest strap would pair to your phone, the phone would then send stats to the wearable. Or you could have some other fitness gadget that you've come up with that doesn't exist. So as a startup, you can make your own custom widgets that measure sweat or heart rate or blood pressure or whatever, and you could communicate that data to the phone. The phone then sends the information to the display here, but everything doesn't have to be done from the display. So the OEMs get to decide what functionality goes in each watch, but if the watch doesn't do what you want, you can integrate in other devices. That device will not pair to the watch, it'll pair with your phone. The reason we do that is because your phone has a much larger battery compared to this thing here. Most wearable devices, you want to minimize the amount of time you spend processing things on here. You want to try to do as much as you can on your phone because this is where you've got a bigger battery and you can dissipate more heat and things like that. But yeah, so the OEMs control what hardware goes in. Yeah.
Do you maintain any audit or info of things the user did on the phone?
To do what?
Supposing I use the phone to say to control an IoT device or something,
Okay.
I want to maintain a log of what was done. If it's in the cloud, that's okay. If it's in the smartphone, it's okay. But do you do anything?
I mean, Android doesn't do any of this stuff by default. I mean, if you want to make an app that logs something, you could put that logging in yourself. But this is just an Android device, just like this is. There's no logging of if you turn your lights on or off. You would do that yourself if you wanted to. Yeah. Any question? Oh, yep. I don't know. I mean, a lot of that comes down to the OEMs. The problem with a watch is that where do you put the fingerprint scanner without taking space away from the watch face? So, yeah, I don't know what they're up to with that, but yeah. One more question, then we have to finish up. Yeah.
So if the app wanted to do like a guided sequence of events for the user, you could do that either with the custom app or you could do that with the like a series of notifications.
Yeah.
And the person with the custom cards thing, the person could actually respond like, yeah, I'm done with that step, I'm ready to move on.
Well, the other way you could do it is with like a geolocation thing, which is where if I detect you've reached the waypoint of where I've told you to go, the card would...
Like a guided gym, a guided fitness app inside
Ah.
the gym or something like that, where
Yeah.
you've got a set workout that you're doing,
Mm-hmm.
and you just want to...
Yeah, you could do it with notification cards, or you could do it with a custom app. There's actually a really cool app that launched at Google I/O called All the Cooks, which was actually a cooking app. And it's actually really neat because what happens is you're looking at the recipes on your phone and you say, yeah, I want to make curry chicken. So you click on it. And then it says, okay, heat the oven to 350. So then you dial your oven to 350 and then you tap the screen, next step. And then it says, cook for 5 minutes. So you tap the 5 and it actually sets a timer for 5 minutes automatically. And the other cool thing is that if your hands are dirty, you can use your nose to swipe the notification cards. So I thought that's not something they came up with, but I did it the other day. I was like, all right, I need to, yeah. And I used my tongue one time as well. But so that's the cool thing is, I mentioned this before at the start of the talk, is what could exist, what app could not exist before that can now exist with a wearable? Problem with phones is they've got lock screens and, you know, how do you mount it in your kitchen so that your phone sits nicely so you can look at it? And when you're at the stove, you don't want to look at your phone on the other side of the kitchen. So I really thought they nailed the user experience. And that was actually one of the very first Wear apps to come out. And they just nailed it. So I'd definitely check that app out as a good way of building like a recipe guidance system, which could be used for anything like maintenance tasks or whatever. There's a lot of cool possibilities there. Cool. All right, well, thanks very much, everyone. I'm actually speaking at this meetup tonight that's part of this conference as well. So I'll be there and I'll giving a slight version of this talk and then we'll be showing some Android Studio and stuff like that if anyone wants to come check it out. Thanks very much.